Very good morning to all of you. Welcome you guys. Welcome you all. How you are doing, everybody? Welcome you guys. Welcome you all. How you are doing, all of you? कैसे हो सभी लोग? think we are live. क्या सबसे पहले टू कमेंट करके बोलिए ना. Is the audio video is clear to everybody? टू कमेंट करके बोलिए. Is the audio video is clear to everybody? Yeah, first of all, a great news to the aspirants who are seriously preparing for 2027 के लिए. So Unacademy का बढ़िया से बढ़िया ऑफर आया, that is Unacademy subscription, that is just कितना बोलिए बोलिए, that is 7,999 rupees only. आपको डबल बेनिफिट मिलेगा. 6 months प्लस एडिशनली 6 months मिलेगा. इसका मतलब आपको पूरे 1 साल का सब्सक्रिप्शन पूरे के पूरे मिलेगा. एंड दिस इज द लोएस्ट प्राइस एवर. एंड सो 100% ऑफ रिफंड फॉर 80 लकी विनर्स को पूरे 100% ऑफ फ्री रिफंड होगा. एंड इसके साथ गेट एश्योर भी है. Enroll immediately. Enroll it. This is the limited period offer. Use the code of BV Reddy and to avail these opportunities. Use the code of my personalized invite code BV Reddy to avail this opportunity. And so just imagine now 7,999. 7,999, that means that is for the 1 साल के लिए. So if you see, calculate now 7,999 by 360 days. That means how much you will get now here. This is एक दिन के लिए. So how much it is now? 22.2 rupees. That means per day you are paying just 22.2 rupees you are paying. Yes, that is simply yes. 20 rupees mean that is 1 liter water bottle का cost है ना. With the just 22.2 rupees per day, you will get the Unacademy subscription आपको मिलेगा. This is the lowest price ever. This so limited period offer. Try to utilize this opportunity before it going to expire. So in my 7 years of incomplete Unacademy journey, you never find this type of offer, right? Now we're starting a new batches. So Agniveer batch. So we are starting a new batch from कब से शुरू होने वाला? So 13th of August से शुरू होने वाला. And we are starting with the EMT subject. So बहुत बढ़िया सा subject है EMT. So many of the student has been requested for EMT के लिए. So to enroll for it, you can use the code of BV Reddy and to avail this great opportunity. Right. So this is a Mahaveer batch for 2028 के लिए. So this is the electrical batch. Yes. And these are the GATE 2026 rankers from Unacademy का team का. So ESC 2025 का rankers you can have a look at now. These many rankers are there. So what we offer here, we offer this प्लस सब्सक्रिप्शन के साथ आइकॉनिक भी आपको मिलेगा. सो आइकॉनिक में एडिशनल बेनिफिट क्या मिलेगा? सो पर्सनल कोच मिलेगा. फिजिकल नोट्स आल्सो यू विल गेट. Yes, and book a time slot according to your time convenience. Connect with your mentor for the proper guidance. So start your serious journey with the Unacademy to achieve your dream goals. So don't wait, shuru karo. So you will get the great knowledge from the Unacademy का team का great knowledge मिलेगा. So start it early, gain early. So चलिए, last we have discussed some problems. As we will continue the remaining problems, will continue. Yeah, take this problem. Now find Vx and Ix in the circuit. Let's find out one by one here. How much the Vx value and Ix value. Yeah, you can see now this current which is given as a 5 amperes. So from this, can you tell me now how much this voltage here? This voltage which will be equal to 40 volts. This voltage, how much you get now here? This is the 40 volts. Next, if this we applied the 60, 40 will be taken by this fellow. That means remaining 20 is across this element. Now tell me now. This is 20 volts, right? Next. So this is 20, this is 10. So how much is the current? You tell me now here. This current is 2 amperes. So this current which we got it as a 2 amperes. Now, so you can tell me now here. So here this current, how much this current is a 7 amperes. And this current, this is 5. This is the 2 amperes. Now you tell me now how much this current will go here. This current which will be a 3 amperes will go now. And that means how much this voltage you can see now. 4 into 3, 12. Now 20, this is 12. That means here this voltage is 8 volts. Right. Now you tell me now 8 volts means how much this current, you tell me now. This current is 4 amperes. And this current which is Ix. And this current is how much, you tell me now, 3 amperes. Now you tell me now 3 amperes are coming here. So this means 4. That means this must be a 1 ampere. So that means we can write it as Ix value. How much is Ix value? Tell me now. Ix equal to 1 ampere. And whatever the Vx value, so that's why Ix, which is equal to 1 ampere. What are the Vx value? Vx value, which is 8 volts. Okay. Got it, all of you? Next one. Yeah, take the next problem. For the circuit shown in the figure, the current I is. The current I. So this means this current we need to get now here. Let's see this thing what we can do. Here they given this current given as 1 ampere. So this current is 1 ampere means we'll find this voltage, and this voltage is 4 volts. And that means this voltage how much this voltage now? This voltage is 4 volts now. So that means this current, how much this current is at 2 amperes. So here already this is 1 ampere, this is 2. That means this current, which will be a 3 amperes. Now, and we'll get this voltage now. If I call this voltage is something Vx. Yeah, you can tell me now this Vx value. Now, so properly visible now, problem? Now you can tell me now here. So this voltage is 4 volts, and that means this current we can get now here. So we need to get this voltage, Vx value we need to get. For this, we'll write the KVL in this loop now here. So how much the Vx value will get, you tell me now? And which will be equal to 4 volts. All of you tell me now. So that is Vx value, this voltage, which is a 4 volts. Okay. Yeah, you can see now here. So that means this current we can get as 1 ampere. That means this current, which is a 4 amperes, right? This current 4 means what we can say now, this voltage 4 into 3, that is 12 amperes. 12 volts. Now, so if I call this is something voltage, if I call this is something Vy, can you tell me now how much is Vy now? So by writing the KVL in this loop, tell me now how much will come? How much the Vy value? So this is 16, isn't it? Tell me now. So this is by KVL plus Vy minus 4 minus 12 equal to 0. So that's why Vy value how much now? Which will be a 16 volts. So this voltage 16 volts. That means this voltage is also 16 volts only now. Tell me now. Then from this we can get this I value. Yes, KVL equations for Vx. Vx case, so here we apply the KVL in this loop now. So this is Vx voltage. Now write the KVL in this loop now. Started here, we are moving like this, like this, like this, and thereafter we are moving like this. Now you tell me now this equation, we have a plus 4 minus Vx equal to 0. So that's why Vx will come to be a 4. Isn't it? Now, so Vy value we got 16 now. So this I value is how much now? 16 by 2, which will be a 8 amperes. Okay. Next one. Now tell me now this problem. Find Ix. Find Ix. Now you can see now first of all how these two resistors you see this thing. So how these two now tell me now these two are in series. So which will come to be what tell me now? This is 14 and this 14 and this 14. How these two are tell me now? Parallel will becomes what you tell me now 7. 14 is what you tell me now 7. And this 7 and this 11. 7, 11. How much is well 18. Okay, 18 and 18 parallel will becomes as what tell me now 9. 9 plus 9, 13 series 22. 22 to 22 parallel will becomes 11. So that means can you tell me now how much the equivalent resistance of this combination? Which will be equal to 11 ohms. Then this is 11. So we'll get this current now here. How much this current is a 4 amperes. Okay. So we got this current as a 4 amperes. Now then this current, this is 4 amperes mean this is 2 amperes and this is another 2 amperes. Okay. Now here at this location 2 amperes of current is coming. Next, from this, what we can see now, here we have the resistance 18, this 18 now. So current will divide equally. So this means this current will go this as 1 ampere, this is 1 ampere. Now again here we have 11 and this is, now you see this thing here. Now, so this current will divide equally. So up to here, this current is 11 amperes will go. Here, this path, which is 14 resistance, this path 9 plus 5, 14 only na. So that means current will go equally will go here. This current is what we can say now 0.5 amperes. This current 0.5 amperes. This current is also 0.5 amperes. Okay, so finally, how much this value of Ix you tell me now? Which is equal to 0.5 amperes. Okay, next one. Find Vx. So here is the voltage now. Find Vx value. So if I call this current is I, this current which will be I, we are writing a KVL in this small loop. Apply the KVL in the small loop now here. Will come to be a what element of 4I plus Vx minus 20 equal to 0. That means Vx value which is equal to what we can say now 20 minus 4I. Is this thing fine now? This is Vx value we got. That means to get the value of Vx, I value required. So I के लिए we write the KVL in this outer loop. KVL in the outer loop. Tell me now here. Yeah, so this is 4I minus 5 plus I plus 10 minus 20 equal to 0. 5I. Now this is 5I, which is equal to what tell me now here? 10, 15. So I value how much now? 3 amperes. I value 3. Put the I value in this equation. Then we'll get the Vx value. Tell me how much the Vx value. Tell me now here. This is 20 minus 4 into I value 3. So how much this value of Vx you can see now here, 20 minus 12, which will be equal to 8 volts. Next. Tell me now this thing. Here up to here this current which will we go, it is 11 milliamperes. Now the current will divide now here. As we know how this current proportional to resistance, you tell me now 1 by R. So can you tell me now this current I now? So I need the current in this branch. So that should be given as 1 by 2 current division CDR. Remember, 1 by 1 plus 1 by 2 plus 1 by 3. 1 by 3 into what you tell me now, 11 milli. So then this I value which will come to be what you tell me now. This is 1 by 2 by. So you can see now here LCM here, which we have a 6 is a LCM, that is 6 plus 3 plus 2 into 11 milli. So then that is I value which will come to be a, that is 1 by 2 by 11 by 6 into 11. So this 11 will get cancelled. So this 11 will get cancelled. 2, this is 3. So this is I value will come to be what, tell me now, 3 milliamperes. Right, now see that this the difference with the previous problem and this problem. Previous problem directly they given the current source, here they given a voltage source is given. That is only the difference here. Now similarly we'll find the first, if I able to get this current now, if I able to get this current now here, IS if I call, we can apply the again CDR. Let's find the current now. That is the source current now. For that we need the equivalent resistance of the complete network is required. So let's find the equivalent resistance of the network first. Now these three resistors are in parallel and then after that series. So that is, we'll write it as what element of 1 by R equivalent, which will be equal to, so that is 1 by 1 plus 1 by 2 plus 1 by 3. So the LCM which is equal to 6, that is 6 plus 3 plus 2, that is equal to 11 by 6. That means R equivalent is how much now? 6 by 11. Plus the series combination of 10 is there. So this is 110. So that is 6 plus 110 by 11. So how much will get? 116 by 11 kilo ohms. Now from this, how much this value now here? This current we need to get now. So what is this IS value? Tell me now. IS value 6 by 116 by 11. Yes, so that is 116 by 11. So this is 6 by 10.5. 6 by 10.5. That is how much is value of current to tell me now? 0.57 milliamperes. Now we will apply the CDR to get this current. Now tell me, apply the CDR now to get this I value. CDR, current division. This is I is equal to same as earlier now, that is 1 by 2K by all K's only will get cancelled. 1 by 1 plus 1 by 2 plus 1 by 3 into how much is into IS. IS value 0.57. 0.57 milli. So simplify, get the value. So this is 1 by 2 by, we have seen this is 11 by 6. 11 by 6 into 0.57. Tell me how much this value will come here. So this is 2, this is 3 here. So that is 3 into 0.57 by 11. Tell me now here, this is 3 into 0.57 by 11. That is, how much is I value? Tell me now, 0.155 milliamperes. Okay. All of you will do like the session. Do like the session, everybody. Yeah, tell me now in this case, the current I is 2 amperes when R is 20. What will be the I value when the R is 10? So if you see carefully this one, the current which is flowing in this branch, this value which is how much now 4 amperes, will it depends upon R pe depend karega? It does not depends upon this R. So R value 0, 1 to any value doesn't matter now. This current always will go it as a 4 amperes only, isn't it? Yeah. So that's why this current so remains same only na. So this is I value how much here, which is equal to 2 amperes only. Okay. So did you understand this concept? You tell me now. If we have this is, there is some current source is there. And here is a resistance you have taken, this is R, and this is 4 amperes. Now you tell me now here, at this location, this current is there, and here there is some other network that has been connected. And this is 20 ohms they given. Now tell me now here, we have some other network they connected here. So if this R value changes, how much this current will reach here? Doesn't matter. Now tell me, this is always 4 amperes only will reach. So that means this direction, this current, initially this current is given as how much now? 2 amperes. So here also 2 amperes only will flow. Even if we change this R value, so here this current will reach here, this is 4 only na. Now after that current will divide between these two paths will divide. Isn't it? Current in the branch will depends upon this resistor and this network resistance, not based upon the series resistance of R, isn't it? So that's why still the current is 2 amperes only. So the answer is how much you tell me for this problem? 2 amperes only. So any queries in this thing, tell me. Right. Yeah, take the next problem. The magnitude of current passing through 3 ohm resistor is. Now here, so we need to get this current we need now. This current, if we call this as I, this I value we need to get. Now tell me now here. This current is I, here this current. How much this current going here now? 120 going here. If we write the KCL at this node, then how much this current you tell me now? This is I minus 120. How much this current you tell me now here? I minus 120. Now here this is up to here I minus 120. Now 70 is joining. That means how much this current tell me now? This is I minus 120 plus 70 will join now, tell me now. Then how much this value tell me now? So minus 120 plus 70. So will come it as what, tell me now? 50. That means I minus 50. Okay. Right. So this means this current is what you tell me now here? I minus 50. And at this location 30 leaving now. So that means how much this current you tell me now this going? This current is I minus 80. And again I is coming, 80 is coming now. That means how much this current you can tell me now? This current is I, 60 going. That means this current is I minus 60. Again 60 coming, so this current is I. That is a KCL. Now, so we know the current in each element. So let's write the KVL in the loop now here. So by KVL, tell me the equation now. KVL, if I start here, at this point we are starting for KVL. So which will be equal to 3I plus I minus 120 plus, this is 1 into I minus 50, next 2 plus 2 into I minus 80 plus 2 into I plus 1 into I minus 60. Yes, that is equal to 0. Got it, all of you? Now you can tell me now here how many i's now here? 3, 4, 5, 5 plus 2, 7, 7 plus 3, 10. So we have totally 10 i's. And which will be equal to how much now? This is 120 plus 50 plus how much now here? 160 plus 60. So how much this value now? Here 0 will get cancelled both sides. Now this value will come, I will come to be how much now? 12 plus 5 plus 16 plus 6. So how much is I value? 17, 17, so 39. So this is 39 ampere. Check it, all of you. How much is answer you got? Right. Next. Tell me this one, how much? What's the answer for this problem? Now this current is 2 amperes. So that means this is positive, this is negative. How much this value you can see now here 10 volts. Right. Here this is 10. So this means obviously this voltage same only na. This voltage is also 10 volts. And this voltage is also 10 only. That means how much this current you tell me now? This current is 5 amperes. And this current is how much now here? 10 amperes. Right. Now you can see now here this is 10, this is 5. Look at now this current which we have, this has a 10 amperes. And here we have this is a 5 amperes. Right. So how much is current coming here? This current is 2 amperes is coming. Right. So, and you can see now here. So this is 10. That means this must be 8 amperes has to be in. So let's write the KCL at this node. So you can say now 8 is leaving current, 5 is also leaving current, and IX is also IS also leaving current only. So from this IS value, how much you can see now? Okay. Minus 13 amperes. Okay. Now we need to get this voltage also. So let's write the KVL in this loop now. Tell me now KVL here. If we start here, this is minus Vs plus 10 plus 10 equal to 0. So from this, how much the Vs value now here? 20 volts. Vs is 20, Is value minus 13. So this is an option now here. And they ask him to find the current through 1 ohm resistor. 1 ohm resistor, this is already 10 amperes. That is option C. Done. Next one. The values of E and I for the circuit shown in the figure is E and I. Yeah, so this is the problems what we are discussing. Those can be applicable for AE, AEE के लिए भी will helpful. The things, the series we are doing, those things are helpful for AE and AEE also. The networks will be perfect. Hmm. Now tell me now here in this case, how much is current? Given 2 amperes, so that means we can get this voltage now. How much is voltage now? 8 volts, right? And this voltage is also 8 volts only. Then how much is current? You tell me now 8 amperes. So that means this is 8, this is 2. That means this current must be a 10 amperes. That means this voltage which is equal to 10 volts. Yes. Good morning, Rajesh. And so this is 10, this is 8. That means this voltage which will be a 18 volts. Then this current which will be equal to how much now? 3 amperes. Then how much this current, you tell me now? This is 13 amperes. Okay. So now we'll tell me now how much this voltage now here, 13 volts now. Now we'll write the KVL in the loop now. So how much will come here? This is plus 13 plus 18 minus E equal to 0. That means how much this E value, tell me now here, which is equal to 31. 31. So, and I value how much now? 13 amperes. Yeah, Sai Kiran. So, regarding the preparation for AE and AEE, and we'll plan one session, will plan AE and AEE के लिए. So, राजेश, मेरा I'm using मेरा English बहुत सरल English यार, very simple English I'm using. Yes, बहुत सरल English हमने यूज करा. So I think so ये शब्द आपको ठीक से पता चलेगा. Okay. Next one. And they given these points A and B, they given. They ask to find if VA minus VB equal to 6 volts, VC minus VD. Yes, I can. So for this AE and AEE के लिए, so for that we have the one special preparation strategy. Will plan it. Don't worry. So there you will get to know how to prepare and all. So exam date has announced or not? Exam date announced. Now you tell me now here. So if I call this current is something Ix, if I say, how much is Ix value, tell me now? Ix, which is equal to basically VA minus VB, potential difference by resistance, right? 2. So that is VA minus VB given, which will be equal to 6 by 2, which will be equal to 3 amperes. Okay, so this current is 3 amperes. Now, so the whatever the amount of current which is going here, the same amount of current has to return again. Right, so that is what we can say now here. So this current which is 2 amperes, and this is, here we have VC, and this is VD, and here we have the some resistance that has been connected. How much the resistance is 1. So you can see now this current, how much this current is a 3 amperes, isn't it? Yeah, we are solving the step by step. We are detailed manner. We are solving. Isn't it, Rajesh? आपको समझ में आ रहा कि नहीं? कोई डाउट हुआ तो पूछो. Now you tell me now here. So at this location, if I call this current is something I. And so can you write the KCL at this node now? KCL at this node. So tell me the KCL now. So I is the entry current plus 3 is also entry current plus 2 is also entry current. So that is equal to 0. That's why I value is how much you tell me now? Minus 5 amperes. I value minus 5 amperes. So that means at this I means what, tell me now? Basically this current now I means I will write this I is equal to, that is VC minus VD by resistance is 1, which is equal to minus 5. From this we can write as VC minus VD, which is equal to minus 5. Right, all of how to find. This is the junction is a node now. This node is given. E and B in the problem itself, they have mentioned that these are the nodes given. E and B are the nodes they given. Okay. So this is A, this is B, and this given as node C and node D. All of you do like the session. Like the session, everybody. All of you. Next one. Yeah, so you can tell me now here. So let's write the KCL at the junction. KCL at the junction. So tell me the KCL now here. And this current, put this current. So how this current, if I call this as a IR, and this current which is at 2 amperes which is entering, if I call this current as a IC and this current as a IL. Now let's write the KCL at this node now. Sum of entry currents equal to 0. That means here sum of entry currents equal to sum of leaving currents we can apply. So you tell me now here IR is a entry current, and so 2 also entry current, and IC is a leaving current, and IL is also leaving current. Okay. Now IR, so this voltage IR, we are given 5, the resistance is 1, so that is 5 by 1 plus 2, which is equal to, tell me now. So this is IC. I is equal to what, tell me now? C into dV by dt na. I equal to C into dV by dt plus what you tell me now? IL. Now this is 5 plus 2, 7. So from this we can get this as what, tell me now? IL is equal to. So that is 7 minus C into what, tell me now? D by dt of what, tell me now? Voltage across capacitor, they given now how much this value? 4 into sine 2t given. So from this we can get this value of IL. How much now? This is 7. C value how much now? 1 into 4 into 2, 8. This is will come to be a 8 into what, tell me now? Cos 2t. This is my IL now. So we need to get the VL. What is the voltage across inductor? That is L into what we have, tell me now? DIL by dt. So this is inductor voltage given as 2. This is 7 minus 8 into what, tell me now? Cos 2t. So which is equal to 2 into this, sorry, this derivative now. 2 into, this is d by dt of, so this is 7 minus 8 into cos 2t. Now simplify and get it now here. 2 into what, tell me now here? Minus 8 cos derivative sine into 2 into, that is cos 2t. Sorry, cos derivative minus sine na? That is sine 2t. So how much will come here finally? 8 into 4, 32. So 32 into sine 2t. So this is what, tell me now? VL. Voltage across inductor. How much is value? 32 sine 2t. In the figure, the value of resistor R. Here the R is not a fixed value, it is a variable resistor. It is a variable resistor. They given it as 25 plus I by 2, where I is a current in amperes. Now they asking to find what will be the I value. So we can write the KVL in this loop now. If we write the KVL, so tell me now here. So this is I into R minus 300 equal to 0. This is I into R value, how much now? 25 plus I by 2 minus 300 equal to 0 now. If you multiply this thing, it will come to be I square by 2 plus 25I minus 300 equal to 0. So that is, we can say now I square plus 50I minus 600 equal to 0 now. Now you can tell me the roots now here. I 600. So that means how much will come? 60. Yes. I minus, okay, plus 60 into I minus 10. Check it all of you. Will get now. So this I value will come it as a plus 10. This is one option. I value is a minus 60 is another option. But see, the direction of current is given right side now. So this could not be the option. This is only the option. Okay. Right, all of you. All of you do like the session. Done. Okay. Solve the problems now, everybody. So, right. Fine. Yeah, that's it for today's session. So here next class will continue the remaining problems. Okay. चलिए